Hello, how's everybody doing? All right, did you guys get my email this morning? Yay. So we're going to start with that fraction, page 9 and 10 that I emailed you. And I just gave you all the pages because I think that some of you, would like the extra practice to go through them. All right. All right, somebody's on iPhone. I don't know who that is. Has it changed already? Did you guys rename yourselves? No. Oh, it's Karina. Sorry, Karina. I can see you now. I was looking at my list instead of your face. So, okay, good. So I was just looking at your rational number homework. Not sure if you guys are just overwhelmed or what's happening. This isn't to everyone, and we'll talk about it more on Monday. But I don't know if it's a directions thing or what. But on the directions on that assignment, it tells you what you're supposed to be doing. And so, for example, it says, solve the following problems. Include drawings and all solutions. Be sure to show all of your work and explain your reasoning. Write your answers in a complete sentence. Some of you didn't do all of those things. You did some of those things, but you need to do all of those things. So just a picture and an answer is not an explanation. Explanations are in words. So you should have a picture, you should have an explanation, you should have your answer in a complete sentence. Yeah, and you should show all your work. So I'm going to go through those this weekend. I was going to try to go through them before class, but there was no time. And pick out some answers and have you guys, I'll take off all the names. I'll have you guys look at them and see which ones you think are good answers and which ones you think did not give complete answers. So please make sure you really attend to precision. There were only 4 questions, right? So it shouldn't have been that terrible. 4 questions. Okay, I know the digit problem was super fun. Yeah? Did any of you start crying with the digit problem? Yeah, it's a stressful problem. Okay, did you post anyway? Even if you didn't have an answer. Okay, because maybe you thought, I'm close to the answer, right? Okay, so I talked to some people in office hours last night about the digit problem. Yeah, and Jessica had almost finished. Kelsey was on her way. And Kelsey, did our info last night in our office hours help you on that digit problem?
Yeah, like definitely it helped me like limit it down.
Yeah. Some of you guys had a strategy of guess and check, I'm guessing. Am I right? Boy, there's a lot of guesses there, right? You could do that math using the fundamental counting principle. How many possible choices could I have had? It's a little overwhelming. If you spend a lot of time on step 1, making sense of the problem, you will narrow down your choices a lot more. Okay. How many of you got an answer that you know is correct? Yeah, look at that. So some of you, oh, Madison, you either know or you don't, right? You were like, Madison was like, no, you know or you don't, right? It's either correct or you're like, no, I know mine's wrong, but I had to put something up there, right? So the one that was the hardest for you was the 7-digit, am I right? Yeah, you feel the pain of that 7-digit because there's no rule for 7, or there's kind of a rule, but by the time you figure out the rule, you could have just guessed. So 7 was the gotcha question, right? 7 was the one that could really be a pain in the butt. So, and I made a huge assumption when I did mine, let me tell you. My huge assumption was I hate 7 and I can't figure it out. So I'm just going to put it in the 7th digit and hope that's right. That is literally exactly what I did. And I wrote it down on my assumptions. I was like, here you go. I'm just going to assume 7 is in that 7th spot because I don't know where else to put it. And then if it's not in that 7th spot, I'll deal with it later. So I don't know if any of you made that same assumption, but that was mine. Okay, so I know we're going to do adding and subtracting with pattern blocks. You had your worksheet yesterday, right? Everybody shakes their head, yes. Look at that. Oh, that. And now we're going to look at that, Tyler. Right now, we're going to look at page 9. Okay, we're going to look at page 9 of that right now. He was holding up that fraction thing. So I'm going to pull it up on here. And notice there's a bunch of it. I'm just going to go through it briefly so you kind of see it would progress. It would start with page A, where it's like we're just looking at unit fractions, right? And so notice all of those fractions have a numerator of 1. Okay, and this is a great activity. Normally when we're in class doing this, I have laminated sheets and you guys write on the laminated sheets and you work at your own pace. And then I just come around and check them. It's a great thing with kids. You just have them hold them up, right? Or you walk around and check, and then they just wipe them off. It's awesome. So that's where we start. Number lines. Notice number lines, right? Then look, I added some negative numbers. Now in elementary school, you wouldn't add negative numbers, right, to your number lines. But in middle school, you totally could, right? Okay. Then these are fraction bars or rectangles. So it's good to see a different model, not just number lines. Now let's look at rectangle.
You're not sharing your screen.
For pickle's sake. Thank you so much, Bethel. I thought I was, and I'm not.
I'm
glad you were-
because I thought you were explaining stuff, but then I was like, no, she's going way too far. We don't know anything what you're talking about.
I was hoping you guys were following along. Tyler was, right, Tyler? Because you have the packet in front of you. If you had the whole packet in front of you, you might have been still catching on. Okay, now my iPad decided to be a moron. So, okay, hold on. I got it. Am I sharing my screen now? Yay. Okay, let's start back. Here's a little refresher. This packet is a lot of information. We're only going to look at a little part of it, but you could do it all if you wanted to. It'd be great practice if you're struggling with fractions. So it starts off with unit fractions on a number line. The second page has negative unit fractions. Again, you wouldn't do those in elementary school, but you could in middle school. The next page starts with fraction bars or rectangles, right? Notice all my units are the same size. This is a great way to remind students of that. Remember when they draw their craziness? My daughter was doing fraction strips. Have you ever seen fraction strips? My daughter was making fraction strips, and she made them at school and brought them home and was trying to do her math homework. And a fraction strip is like a piece of paper, and like the first line is a whole, the second line is cut into two pieces, or it's labeled half, half. The third line is third, so 1/3, 1/3, 1/3. The next line is 1/4, 1/4, 1/4. Well, the teacher had them make their own fraction strips. Great idea, right? Until she brought her fraction strips to me, and one of hers, it goes up usually through 12. So if you can imagine, she drew them on a piece of paper. So there was her 1. Here was her 1/2. And then her 12th was like this. So maybe you can see this. I know I wrote in orange, so it won't be great. So there was her first one, a unit and then a half. And then there was her 12th. It was so much longer. It was like this long. I was like, how did you even make that out of paper? Like, it was crazy. So manipulatives are not helpful if they're not mathematically accurate. So be careful, right? It might be worth it for you to bring the fraction strips home and cut them all out for the students, or have a pattern for them to cut them out. Cutting and kids takes a long time. Have any of you had kids cut stuff out in a classroom? It's a nightmare, isn't it? So like, if that's your skill that you're teaching in kindergarten, more power to you. But if you're in 5th grade and you just want them to have the materials, figure out how to get them cut out before you get to class, right? Like, have a mom parent help you. Yeah, because I agree, it's a time consuming, but boy, oh boy, you will lose so much time in class if you have your students do it. Okay, so rectangles. Now look at these. This is kind of what we did yesterday, right? And it starts with unit fractions. So if you struggled with yesterday, we'll do a tiny little bit of a review of this one. So here's my example, 1/6 of the triangle. So that means I need to have these triangles into either groups of 6 or 6 equal groups. I can do either one, right? So first, I'll do 6 equal groups. So 6 equal groups would be this. There's 1, 2, 3, 4, 5, 6. So that means each one of these must be 1/6 in size. So then I just wrote it right over here. 2 triangles is 1/6. Does that make sense? So that's one way to do this problem. Or you could do like this, and I can't remember who did it yesterday, maybe Bethel, but the other way to do it would be to say, oh, I see that I have 6 here and 6 here. If I take 1/6 of this one and 1/6 of this one, then I would have 1/6 of the whole. So I would still have 2 triangles over here. So two different schools of thought, right? Do I want groups that are 6 in size, or do I want 6 equal groups? You can think of it either way. One's not better, it's just different. Okay, and then you can see there's lots of other ones. So some of them are easier than others, like this one. If we do 1/3 of the triangles, if I draw, sorry, I'll do it like this. If I draw a line like this and like this, you can probably see 1/3, 1/3, 1/3. So there would be 4 triangles over here. Make sense? But on 1/4, I could draw my lines this way. Yeah? And so I'd only have 3 triangles here. You okay? Everybody hanging in there? Okay, good. Now, when we move on to this, notice now I don't just have unit fractions. Now I have fractions that have a numerator other than 1. I also have some improper fractions here. Do you see that? So this is moving on, right? After they understand unit fractions, then you'll move on to, okay, this is 2 copies of 1/3. So if I knew where 1/3 was, I just need another copy. So that's why you build on that copies of idea. Okay, so that's what's next. And then of course, negative, which you would only do in middle school or higher. And then fraction bars, which we did this little tiny bit the other day with maybe you need to draw an extra rectangle, right? And notice it's very faint on here. You can see those little dotted lines if they need another rectangle. Okay, so then they're not free-for-alling it in elementary school when they have trouble with that. But this is what I want to do. I want you guys to try a couple of these. So 2/3 of the triangles, then 5/4 of the triangles, and then that's 5/4 of the triangles, but with a different amount of triangles, and then 4/5 of the triangles. So if you have this worksheet, this should be page 9 and 10. Try some of those. And if you want, I can show you this first one. It says represent 3 halves of the triangle. So I needed all of this. I needed all of this, and then I needed another copy, right? So if I split this into 2 pieces, there would be my 2 pieces. So I need 3 copies of 1/2. Well, there's 1 copy of 1/2. There's another copy of 1/2. So I needed to add another copy of 1/2. So I needed to add another set of triangles. There is a mathematical way with symbols you can do it, like numbers, but I wanted us to do it visually first. If you're super duper stuck in a minute, I'll show you with numbers. So try these 5 problems. 1, 2, 3, 4, 5. Yeah, no, 1, 2, there's 4. There's only 4. So try those 4. And if you don't have them, like if you don't have that worksheet, hopefully you have it electronically so you can see the pictures. Otherwise, I can scroll down on the screen if you need to when you're ready. Okay, I'll give you about 3 minutes. All right, how'd you do? Did you finish? Yes? Okay, good. So somebody explain number 1. You can share your screen, you can hold up your board, you can talk me through it, I can write for you, whatever you want.
I can do number 1.
I'm ready.
Okay, so I did it horizontally and I circled 4 triangles in 3 different groups. And then, so to show, and then I wrote 1/3 on the top one, 2/3 on the second, and then 3/3 on the last one. And then I just drew 8 triangles in this next box.
Okay, so 8 triangles here. Those are really good triangles. Don't pretend they're not. It's okay. Now, there's one thing that I would disagree with, not your answer, it's your labeling. Does
Okay.
anyone know why I would have a problem with this? Tyler?
They'd each be 1/3.
Yeah, they are each 1/3 in size. So don't label them 1/3, 2/3, 3/3. I know what you were thinking, right? But to be precise, we will want to make sure we label each one of them 1/3.
Gotcha.
And that kind of really helps students with reinforcing the idea of 2 copies of 1/3, right? All right, good job. Was that Alyssa? Good job, Alyssa.
Yeah, thanks.
All right. All right, let's look at 5/4. How'd you do that one, somebody? Let's hear from somebody who's kind of nervous, like doesn't know if they have it right.
I can go.
Okay.
So what I did was I did it electronically. So I broke it down into 4 the rectangle in 4 parts. So I went down like 1 line down. Yeah, like that. And I know that each part is 1/4, 1/4, 1/4, and 1/4. And since I need 5/4, I have to add an additional pair of triangles. So below, I don't know if y'all can see this, but I wrote another pair of triangles, and I shaded in 1/4 to make 5/4 of a triangle.
So you made a whole nother group like this,
Yeah.
and then you knew you needed one more
Mm-hmm. And
fourth.
so I shaded in 1, yeah.
So
And
in this box, how many would you put total?
I would put 5 rows triangles. So
How many triangles? Tell me how many triangles.
15 triangles.
15 triangles. Everybody agree? Very nice. Try to use your copies of language,
Okay.
right? Since I needed 5 copies of 1/4 and I only had 4 copies of 1/4, I added another copy of 1/4, which is 3 triangles. If you have students that are really struggling, you can have them identify that. You can have them right here that 1/4 or 1 copy of 1/4 is 3 triangles, right? Or you can have them draw the unit. Good job, Bethel. Questions on that one? You okay?
I have a question.
Yeah.
So I think this is what's confusing me, and I think it might confuse the kids too. Like, how is 3 triangles in one column 1/4 instead of 1/3? Like visually.
How many groups are here?
There's
4.
Okay.
Yep. So they would see it just what you want them to connect it to is a rectangle. They would recognize this as fourths. So they did the same thing. They split it this way into fourths. And you're not doing this for them. They're doing it, right? They're investigating it because you will have a kid who goes like this. Let me see. You will have a kid who goes, I don't know. I did it this way. and each one of those is a fourth. And then I only had 3 copies of 1/4, so I needed 2 more copies. And that's when your questions come, right? Or your students around them are asking each other questions going, wait a minute, how are those fourths when I only see 3 groups, right?
That's what I did for the first one, but I did it the other way because I kept looking at them like columns instead of rows. And I was honestly a little confused until I saw it like that. And I was like, I don't know why I didn't think of that. Like, obviously, but I was that student just now.
Yeah, and that's perfect because it's new to us. It's a new thinking. People haven't asked you to do this before. People just told you how to do fractions before or gave you fraction circles and they always looked perfect, right? Not like when I broke your brains yesterday, right? They always looked perfect. And so we train our students into not thinking differently. What we need is different thinkers. We need all those kids in your class. You'll have kids do all kinds of crazy things. And that's why you need to be real knowledgeable in your math foundation so you can have these great deep conversations with them, even with a second grader. And they can, that's why you really impress vocabulary on them and your models are consistent and you're very careful because they will say amazing things. Remember I told you about that second grader who was like, I respectfully disagree with your mathematics because, and I was like, what? Yeah. So it's really your modeling that makes a huge difference. Good question, Karina. And thanks, Evelyn, for saying that, because I guarantee you weren't alone. Any questions on number 2? Okay, let's go to number 3.
Sydney in the chat asked, why did you shade the first column?
Oh, I didn't. Bethel did.
Yeah,
Bethel said she shaded it. Why?
Because I knew that I needed another column of triangles. And so that's just another visual for me. And so that's why I shaded in the first column to know that, oh, that's another copy of 1/4 that I needed to make 5/4.
Exactly. So she was saying, oh, all these are shaded and that's the whole. I need 1 more 4th because these were her 4ths. So she just drew a whole nother unit, right? So she just duplicated this whole box and then said, but I only need 1 column because I only need 1 more copy of 1/4. Hannah, was your question on number 2? Sorry, I just saw it in the chat. Okay, and did I answer it yet or no? Because I was just talking about that, but I'm not sure if I went over it.
I think you briefly mentioned it. I'm still confused.
Okay, so let's look at it. Hannah's saying that can we draw a line horizontally and then add 2 more rows? So let's talk about that. I can do that, right? I can do that, add 2 more rows. But let's talk about what these mean. So if I have my original box right here, and I know that's the whole, right? That's the unit, that's the entire group. Then when I split it horizontally with those 2 lines, how many groups have you created?
There's 3.
There's 3 groups. So if you have a whole and it's split into 3 groups, what size is each group as a fraction compared to the whole?
Is it 1/3?
Yeah, so these would just be thirds. But I don't want thirds, I need fourths. Does that make sense, Hannah, why we can't just split it horizontally? Because we split it into 3 groups. We didn't want to split it in groups of size 4. We wanted to split it into 4 groups. If we split it in groups of size 4, we could do this, right? Let's make sense of this. We could split it into groups of size 4. Okay. But I need 5/4 of each one of these groups then, right? So right now I have 4/4. If I want 5/4, I'm going to have to add a triangle to each row. Does that make sense? Why I would add a triangle to each row? These still aren't fourths, but if I'm saying groups of size 4, and I want 5/4, I'm going to have to add another triangle. Do you see how I still get the same answer of 15 triangles? All right, it's a little tricky. How about this one? 5/4 of the triangle, right here. What did anyone do for this one? Number 3.
I can go for that.
Yeah, what'd you do?
Okay, so looking at it, I just counted out how many triangles. So that way I knew a base of, okay, I had in this box, 1 unit is 16 triangles. In order to get to the fourths, my brain automatically knew that 1/4 of 16 was 4 good grief, yeah, 4 triangles. So what I ended up doing was splitting it into groups of 4. So because it's in a weird pattern, yeah, I just kind of had to circle around in such a funky way as to get 4 groups of 4 triangles. Now that I knew this, all I had to do was add 1 more fourth or 1 copy of 1/4 to the whole unit there and add 4 more triangles into the new box there on the right to be getting 5/4 or 5 copies of 1/4.
Nice strategy. Nice explanation. Now, some kids get annoyed drawing all the triangles, right? So especially when you do this a bunch, especially when there's not really a pattern. So you'll get some snarky kid in your class that just goes like this. And you're like, wait, I wrote that on my paper. Am I the snarky kid? It's okay if you are, because I am too. So, and it's fine as long as they can explain to you how they got it. I accept that, right? Because for some kids, fine motor skills are very challenging, and drawing those 20 triangles is going to take them 10 minutes to do. So it's okay as long as they can explain their thinking. Did anyone do it differently? Does everybody agree with Tyler's 20 triangle? All right. How about this last one, 4/5?
I can do it.
All right, Hannah, I'm ready.
Okay, so we're trying to find 4/5 of the triangles. Is it safe to say that the denominator represents the number of units in the whole, or in this case, the number of groups of triangles in the whole?
The number of groups of triangles, yeah.
Okay. So it's pretty, the unit is, the whole is pretty, is laid out pretty nicely. So if we draw a vertical line in between each of the sets of 3, we get 5 groups of triangles, and we need 5, so that's 5 copies of 1/5, and then we need 4 copies, so we just take 4 of those groups of 3, getting us 12 triangles.
Nice. What do you think of Hannah's vocab? Good. I hope you guys gave her party hats. Oh, good. And thumbs up. I appreciate that. Excellent. Now, when you do an activity like this, make sure you attend to precision with your students. Make sure they label things accurately and they can speak accurately to you. It makes a huge difference. Did you notice how Hannah said vertical lines? And then the other Hannah L in the chat said horizontal lines on the one she was trying to describe. Some of you keep messing those up. They didn't. They said them perfectly. But I'm saying that's something that's learned. If we don't practice saying those things, we'll have trouble. So if you learn to say those things in second grade and you keep saying them, you'll get them correct. Yeah, excellent. So keep practicing that vocab. Now, we haven't really talked equivalent fractions, but I'm going to show you a little thing. And it kind of goes with what Tyler was saying before. So how many total triangles are in this original unit?
15.
Yeah, there's 15. So I have something out of 15, and I want 4/5. Do you remember making equivalent fractions? Yeah. So if I'm using a scaling strategy that we'll talk about next week, what did I multiply 5 by to make it 15? I multiplied it by 3. And since the rule for fractions is I'm really only allowed to multiply a value of 1, or I've changed the fraction. So whatever I did to the denominator, I actually have to do to the numerator, because what I'm really multiplying by is 3/3, which is 1. And then 4 times is 12. Do you notice that 12 was the answer to how many triangles go in? It's not a coincidence. That may help you with some of the more complicated ones, right? And thinking about what the unit is really important. Thanks, Liz. I appreciate that. Okay. Did this help some people with thinking about fractions a little bit differently again? Another way I showed you this is this extraordinarily similar to one of your oral exam questions. I'm just saying. Did you get my email about the oral exam questions? They're up, right? Okay. I was almost ready to put up the appointments, and then I was like, ooh, if I put up the appointments and I don't send the email, somebody's going to be mad. So right after class, I'll put up the appointments, okay? Does everybody hear that? Right after class. I mean, it takes me like minutes to set it up. It's really dumb, and usually I do it wrong 2 times I do it, just so you know. So about 15 minutes after class, let's say by 2 o'clock, okay, they'll be up. Okay, notice this goes on and talks about equivalent fractions here, and it even gives you some scenarios of same denominator, same numerator. So those would be kind of fun if you need those. Okay. The one we didn't talk about the other day was benchmark fractions. Larger than a half, smaller than a half. That's a really nice way to compare fractions, right? Like if I give you a fraction like, let me see. If I give you a fraction like 2/5. No, let's not do 2/5. Let's do 2/7 compared to 5/8. Some of you are like, oh, I know 5/8 is bigger than 2/7, but kids might not know that. Or they might just have an error in their reasoning. They might say, oh, the 5 is bigger than the 2 and the 8 is bigger than the 7, so it must be bigger. That's not real mathematical reasoning, right? So this would be a nice one to do benchmark fractions with, right? So this is less than a half. This one's greater than a half. So I know that 2/7 is less than 5/8. I could have just used this one, but you could do this one on your own. 3/4 and 7/16. That's a nice one, right? Because kids might not know which one's bigger, 3/4 or 7/16. Okay, so benchmark fractions are really nice. So that's that whole packet. I mean, it goes more. Here's comparing, but It's kind of a nice packet. I like it. And like I said, I have these as laminated papers, so I could do it as a warm up any day I want, right? And you don't give them all out, right? You just have them do a couple. Okay. I do have to do one other thing, but I'll do it. If I don't do it today, I'll do it next week. Somebody remind me, hopefully I don't forget. I'll write myself a note right now. I need to talk about finding a fraction between two fractions. Yeah, it was in my slides, but I didn't really talk about it. So like, for example, if I was trying to find a fraction between 3/7 and 4/7, some kids would say there's no room there, right? I can't find a fraction between these. But there's plenty of room between them, right? The denseness of rational numbers, I can keep cutting these into smaller and smaller pieces so I can find space in between there. There is space in there. There's an infinite amount, right? Maybe, close, a lot, yeah. So we can talk about that. And I have it in my slides. Okay, any questions before I go back to adding and subtracting with pattern blocks? Deep breaths. Everybody take 10 seconds so they can get their mind back in this new frame. This was yesterday. Welcome back. We had a fun time last night, didn't we? Kelsey, Bree, Jessica, Sunita was there, right? Yeah, we had a good time last night. It was helpful, don't you think? Okay, good. So if you're not busy on Wednesday night, hey, I was just looking at our calendar. We literally have 8 days left of class. 8 days. Yeah. Thanks for that deer in the headlights look there, Tyler.
I can't believe this semester or this class is already almost over and the next one's going to begin. It's just going by too fast.
It is. It is too fast. So, but it's okay. You'll still be digesting some stuff in 257. You'll go, oh, that makes so much sense now from 256. Some of us just have it. The processing is just not complete. Okay. So everybody remember what we were doing yesterday. We were trying to rearrange these equations so we could have all the same color. And I'm going to take a step back and say, I'm going to do number 1 again, which sounds really dumb, but it's very important. Let me get this up, the pattern block. It was a yellow plus a red, right?
Yes.
Okay. I'm going to reframe this for you because I think maybe I pushed too fast yesterday. You're telling these kids that you're joining these together like addition. But when they try to tell you what the answer is, they can't tell you. They say, okay, now we have a red, yellow. Maybe it's an orange now. I don't know what it is when we put those things together when they're not the same. So you teach them to make some trades and you say, oh, well, can I make them look the same or be the same shape? Well, yeah, I can trade a yellow hexagon for 2. Yeah, I still can't turn these. I try to turn them. Oh, there we go. I can trade a yellow hexagon for 2 red trapezoids. Now that they're all the same color, I can describe it very accurately. I can say now I have 3 red trapezoids instead of I have a red yellow or a yellow red, right? So that's the idea here. We're trying to describe these accurately, so it makes it much, much easier when we have the same color, okay? And you could say, if you have kids who like the word same shape better, because we have both there, right? We have the same color and the same shape. So now we're down to number 4, where we have a yellow hexagon and a green triangle. So if you want them all one color, you don't have a lot of choices on this one because you can't make the yellow one. Sorry, you can't make the green one a yellow one because it's too small. You can't make any trades. But you can trade this hexagon. I really want these to snap into place. You really can trade this yellow hexagon for 6 green triangles. Do you agree? Okay, so on your paper, you would write in the new boxes, 6 green triangles plus 1 green triangles is 7 green triangles. Everybody okay? All right, I'm gonna give you about, I don't know, 5 minutes. I don't think it'll take you longer than that to do 4, 5, 6, and 7, but only part A. Okay, I'll give you 5 minutes to do part A on those. So, and then we'll talk and we'll do part B, and I'll give you instructions on the subtraction. Okay. All right, so go ahead and work. Let me know if you have any questions. All right, did you do okay? Are you done? Okay, good. So let's just go through this part. When you did yellow hexagon and green triangle, you traded, we did that one together kind of, so that was 6 green plus 1 green is 7 green. And then for the next one, 5A, Bree, what'd you get on 5A? I don't know why it won't let you talk. You're unmuted, but it's not hearing you.
You can't hear me.
Oh, now I can.
Okay, now you can hear me.
Yeah.
Did you hear that I said I was working on 1A because I'm very confused and I was trying to figure it out because I have the 6 green part, but I don't understand how you get 1 green.
From number 4?
Yeah.
So the problem was 1 yellow hexagon plus 1 green triangle.
So is it just like because it's 6 green triangles make?
Yeah, so 6 green triangles made 1 yellow hexagon. So I traded my yellow hexagon for 6 green triangles, and then I already had 1 green triangle. I didn't need to change it.
Okay. Because I didn't know what to
But-
put for the second box, so I guess 1 makes sense.
Yep. Okay, so now, McKenna, what'd you get for 5A?
I'm actually finishing that one up right now.
Who has 5A answered?
I have it.
I do.
Okay, I'm ready,
Uh,
Betty.
I got 6 green and 4 green, which gave
6
me
green and 4 green.
10 green.
Very nice. Anybody get anything different?
I did. I don't know if it's right though.
What'd you get, Alyssa?
I put 4 blue plus 2 blue equals 6 blue.
Let's write that down. 4 blue plus, did you say 2 blue?
Yes.
Is 6 blue. Yeah, so let's make sense of that. If you have true red trapezoids, how many, if you have 2 red trapezoids, you really have 1 yellow hexagon, right? How many blues fit inside 1 yellow hexagon? Is it 4?
Yes.
Are you sure, Alyssa? Let's go look.
No, I think it's 3.
It's 3. I agree with you. It's 3. So do you see how this 4 blue would actually be 3 blue?
Yes.
Okay, so 3 blue and 2 blue is 5 blue. Do you agree that that's equivalent? Is everybody okay with that? Because 4 greens is 2 blues. And 2 reds is 3 blues. Yeah? So you could do it either way. I don't care. That's why I asked, because I thought somebody might have done it differently. Okay, how about 6A? 6A.
I
Who
got
has
a,
one? Go ahead.
oh, sorry. I got 6 green plus 3 green plus 2 green plus 1 green. Equals 12 green.
Everybody agree with Vanessa? Questions, concerns? All right, good. And how about the last one, 7A?
I got 6 green plus 6 green plus 2 green plus 3 green for 17.
Anyone agree with that one? Yeah, it really helps if you're using a manipulative with it, right? It really makes a difference, or at least if you've written some key somewhere. Okay, so what is this game all about? What is happening? Do you remember at the very beginning, we wrote our key of things meant. A double hex was 1 whole, a hexagon was 1/2, a trapezoid was 1/4, a rhombus was 1/6, and a triangle was 1/12. And I'm gonna write the colors in just in case people forget. Okay. So what we're going to do on the second line is we're going to write in our mathematics. So a yellow hexagon was 1/2. So I'm going to write 1/2. That's what it was asking me. It was to do 1/2 plus a trapezoid, which was 1/4. I'm not going to write in the answer yet. 1/2 plus 1/4. I'm going to write in what I did with my pattern block. So right here, when I changed from 1 yellow hexagon to 2 red, that means I have 2 copies of red, or I have 2 copies of 1/4. So 2 copies of 1/4 is 2/4. Then I had 1/4 already. And since I have 3 red, now I have 3 copies of 1/4, which must be 3/4. So my answer to the original problem, 1/2 plus 1/4 is 3/4. Do you see what I did? Yeah. So we're just directly translating what we did with our pattern blocks, but now using this key. So again, 1 yellow hex is 1/2. A blue rhombus is 1/6. Does everybody see where I got that from? It goes back to my key way up here. So now when I switch to 6 green, greens are 12ths. So now I have 6 copies of 1/12. So that's going to be 6/12 plus 2/12 is going to be 8/12. Some of you are like, don't like that. Don't want to write it like that. It's okay. It's fine. We're just learning this. So, and now remember up here, we wrote that there was an alternate. I can't remember whose this was, but I liked it. It was good too. So I'm going to write it right underneath. If we went to blues, we're only at 6. So we have 3/6 plus 1/6 equals 4/6. Is 4/6 equivalent to 8/12? It is. Do you know how kids would know it's equivalent? Because they would see the pattern blocks in front of them, and they would see that they make the same amount. Okay, so that's, you can write 8/12, you can write 4/6. Is it killing anyone? Does anybody else want to write another fraction because it makes them feel good? You can simplify it if you want. You might have a kid in your class that goes, oh, that's 2/3. And you know what you'll say? Show me. Show me with your blocks how it's 2/3, right? And if they can do it, perfect, move on. And you'll spend time on that. So do you see what I want you to do for line B now on all of these? Excellent. So now that you have the hang of that, I'm going to explain the subtracting fractions part, and I'm going to put you in your breakout rooms to work through it. You're going to do very similar things, but again, go through all of part A first before you do anything. So when we subtract, do you remember the takeaway model? When we subtract, we don't model both things, do we? We only model the minuend. Remember that? Okay, so a yellow hex minus a red trapezoid. So we have a yellow hex, and we're trying to take a red trapezoid away. Do I have any red trapezoids to take away? No. So I'm going to make a trade. I'm going to trade my yellow hex for 2 red trapezoids. Now do I have a red trapezoid to take away? Perfect. I'm going to take away that red trapezoid. I'm left with 1 red trapezoid. So I'll write it on your paper so you can make sure you understand what I'm doing here. So I made a trade. Instead of 1 yellow hex, I made it 2 red. I took away 1 red, and I got left with 1 red. Yes? Perfect. So remember, model only minuend. Okay, I'm gonna put you in your rooms for about 14 minutes. Okay. Get as much done as you can, call me in for help. Oh, you'll notice your groups are a little bit bigger. Your partner pairs with another partner pair. I thought that might be helpful. All right, so let's talk. I didn't get to visit every room. I got to visit a couple rooms, and I know you probably didn't get through all of your subtraction. That's okay. This would be prior to students knowing any rules for adding fractions, right? That's when you would do an activity like this. So it's hard for you guys to do this activity because you already know rules for adding fractions, or sometimes you know the rules for adding fractions, right? So sometimes we pretend we know the rules and we like to make up new rules for fun. So, but can anyone tell me why they think I did this activity? What is this trying to show you? What is the idea with getting the same color and all of that?
Common denominators?
Absolutely, Betty. It's teaching them that, oh, the color of the piece or the shape of the piece is actually the denominator, and it's much easier to add fractions when we have the same denominator. And when we have the same denominator, if you look at the mathematics that we wrote in there, did we add our denominators together? No, we only added our numerators. Why?
Because you're just adding more copies of that.
Yeah, the pieces aren't changing again, right? You still have green triangles. You're just adding more copies of those green triangles. So you've seen a kid probably do this, 2/4 plus 1/4, and they get 3/8. Yeah, that's a very common mistake. It's way less common after you do an activity like this, because they go, wait a minute, where did my, red trapezoids go? Because I had fourths. I didn't magically come up with a new color, right? Or a new shape. So it's very helpful for kids. So I know that not all of you finished that, but it's good to work your way through that and make sure you make sense of it. I don't think your exit ticket's too hard today. Some of you had the exit ticket wrong yesterday because you didn't read that they were circle pieces instead of pattern blocks. So just in case you're wondering why you got it marked wrong, that might be the reason. And then don't forget you have your fraction pair activity to do, right? Make sure you do that activity. You were with your partner just a minute ago, so hopefully you made a plan for how you're finishing that. Okay, it's not due till Monday, right? But I just want to make sure. Okay, let me know if you have any other questions, concerns. This is
I
not
have
the
a
exit ticket I'm
question.
showing you on the screen, is it? Hold on. Yes, I thought I had a new exit ticket. I think it is. Go ahead, sorry.
Betty,
I'm
are you
ready.
fine?
You were talking about, I don't know if you ended up going over it, about the 3/7 and 4/7. And you were
I
talking
did.
about the middle portion. That
Yeah, I
didn't make
didn't
sense.
talk about it yet.
Okay.
Would you like me to right now?
Would you, if you don't mind?
Yeah, no, that's fine. If you need to go, have a great weekend. I'll see you later. Don't forget, 2 o'clock, I'll put up the appointments. 2 o'clock, I'll put up the appointments. If you want to check out what Betty and I are talking about for the next few minutes, you can watch the recording when I post it. Or you can stick around. Doesn't matter to me. Okay?
Yeah, that didn't make sense to me.
Ah, interesting.
Because I know there would be, obviously, like you said, they could put anything in the middle, meaning like there could be as much space, you can divide it as many times.
Yeah.
How would I know how many times?
You can decide how many times you want to divide it in there. Okay, I just want to make sure, does anybody else need to see the exit ticket on my screen, or can I switch to drawing? Okay, I feel like everybody. Okay, I feel like everybody's okay.
Which one are you going over?
I was gonna do how we find a fraction between, oops, I wrote the wrong number.
It was 3/7 and 4/7.
And 4/7. how do we find a fraction in between there? And we could think about it like on a number line. If I drew a number line and I have 0 here and I have 1 here, well, this is 7/7, right? And this is 0/7. And so if I put 6 lines in here, 1, 2, 3, 4, 5, 6, then this is 1/7, 2/7, 3/7, 4/7, 5/7, 6/7. Well, I can see space here. There must be something in there, right? So here's an interesting question. If I just put one line right here in between there, what fraction is that?
That's what the confusing part, because it's like it could be 3 1/2 sevens, and that just
Ooh.
didn't make sense in my head.
So it's this. Do you agree?
Yeah, that's
Yes,
what I
it
was
is.
thinking.
I agree. I don't like the way it looks either, but it's true, right?
Okay.
Now, if you turned it in like that to your teacher would probably be like, no, we don't write decimals inside fractions, right? Okay, so let's pretend we know that that is there, but we don't like what it's called, okay? So let's just pretend I draw a line halfway in between all of these. Okay, so now I did the same thing, but to all my pieces, right? Do you agree?
Mm-hmm.
Okay, so what is one tick mark now? Let's count how many there are. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There's 14 of them now.
So
So
now
this
it would
must
be over
be
14.
14/14.
Oh.
So this must be 1/14. This must be 2/14, 3/14, 4/14, 5/14, 6/14, 7/14, 8/14, 9/14, 10/14, 11/14, 12/14, 13/14, and eventually down to 14/14. So this fraction looks much better to you. 7/14 looks much better to you than 3.5/7. Am I right?
Yes. Oh, okay.
Yeah. It is equivalent to 3.5/7. By the way, do you know what other fraction is equivalent to?
1/2.
Did you even realize that when you wrote 3.5/7 that it was the same as 1/2?
I'm having a mental breakdown.
Betty, here's what's cool is I can do it again.
Don't
right?
do it.
I could go like this in between each one of these, couldn't I?
Yeah, and then it would be 28. Right?
Yeah. Because I took half of each one of them. So then they'd be 28. So then I could see a lot more space in between 3/7 and 4/7, right?
Yeah.
And I could keep going.
Oh, okay.
Does that help?
Yes, it does. I just feel like I was
Yay.
breaking my head for it. Now it makes sense.
And you could, we did it visually. You could do it without doing a visual. I think the visual is very helpful for students. And by the way, I can show you something else too. But if we have this, you could say, oh, I'm going to write an equivalent fraction. I'm going to multiply this by 4 and this by 4 and this by 4 and this by 4. So then I would get 12/28 and 16/28. And then I can see that space in between there. I can see 13/28, 14/28, 15/28, right?
Yeah, because that's what I kept on getting. It was like a half of the numbers, but it just didn't look right. And I'm like, there has to be a different way. And you just explained it.
Yeah, and then look at this way too. If I have 3.5, because that's what we had, right? When we had 3.5/7. If we have 3.5/7, that's really a division problem. 3.5 divided by 7, which is really that 6/7 divided by 7. So 7/2 divided by 7/1, which this is what we're going to talk about next week, times 1/7. And you get 1/2.
You're amazing.
No, it's not me. It's math.
The
Math is
fact that
super
it
cool.
makes sense when you explain it, and
Good, good. Well, I've been doing this a long time.
I need your brain for this class.
No, your brain is coming along every single day. Your brain is growing and making new connections with this. It is.
All right, then.
And
Well,
we're gonna
thank you
keep,
so much.
we're gonna keep going through 257. Some of these connections will become more clear then.
Okay. Well, I
Good
appreciate
job.
it. I didn't mean to take your time, but thank you.
Yay, no worries. All right, any other
Have a good day.
questions?
Yes,
That's
Yeah,
I'm
you
okay.
question.
I'm ready.
We were actually in our group, we were over the subtracting fractions on what we did as a group. So for number 3, since we were only modeling the minuend, I know we didn't go over it all in class, but we were like iffy on 3. So we didn't know if we were like, you got the answer, but we didn't know if we were allowed to do that. But we did 3 green and 2 green. Is that?
That's exactly what you need to do. Yep.
We weren't sure if we were allowed to change since we were only modeling the minuend. So I guess we were just a little confused on that.
Yep. No, you did perfect. That's perfect.
Okay, we're just making sure. And then on the exit ticket, did you want us to, because you said to make sure to be able to explain it visually, did you want us to explain how we got the new fraction, or just the answer on the exit ticket?
Let me look at it. Sorry, I lost it. I had it on my screen and now it's disappeared. That's fun. Okay, let me pull it up again so I can look at it. Okay, so be sure you could explain it visually. The first one where I say convert 3 2/3 to an improper fraction.
Yeah. Did you want us to like explain how we got the improper fraction, or just what we got for it?
On the exit ticket, you'll just write what you got for it. But when you're studying for your oral final, you want to think about, could you explain it?
Okay. Okay. I was just making sure.
Yeah. Good job.
Sweet. And then
yeah.
For some reason, whenever I usually like keep like my windows open, but for some reason, whenever I have something on Firefox, whenever I shut down my computer, it like has to completely close out the tab. So is the pattern blocks the virtual manipulative? Is it in the in our OneNote or in your OneNote?
I can put the link there if you want. Do you want me to?
Yeah, that would be nice.
Yeah, and if you just bookmark this, Vanessa, this will be the easiest way, because this is what I do. I bookmarked this website and I can share my screen and show it to you.
Okay.
I'm going to put it in the chat right now. And then I'll get it from the chat so you can see it. So this website is where I use all the virtual manipulatives from. So you can see them all on this screen. And then whichever one you want, you can just click on it. And then you just push on that one thing and it'll bring that up.
Oh,
so,
that's nice.
Yeah, so I just bookmarked this page with all of them on it.
Oh, I'm going to bookmark it then.
Yeah, it's a great bookmark. And then you can just go, it's just extra clicks. Like if I say, okay, I want fraction circles. So you'd go to this bookmark and then you have to click fraction circles and then you have to push one more button. But that's it.
Oh, okay. Cool.
Yay.
Awesome. Okay. Thank you.
Yeah, you're welcome. Have a great weekend. How about you, Sunita? Question?
Yeah, I just have one question on the exploring the unit multiple.
Yeah.
The unit ones.
Yeah.
On the third row on the first page.
I'm trying to remember where, I swear I put it in here yesterday, didn't I? Oh. Remember when I was looking at it yesterday?
Not sure. I can screen share mine.
Yeah, screen share yours. Oh, I
okay.
probably have to stop screen sharing. Hold on. Okay, there you go.
It's just this one here. I just want to make sure that this was correct. If I can write it like that, or should I just do it too?
Oh, you can leave it like that.
Oh, okay.
You can do it either way. It doesn't matter.
Okay.
On that one, I have no directions about simplifying, so I'll accept any of them.
Okay. That's
Yeah,
not what was my lead.
Yeah, because it's just about your thinking, so you're good.
Okay. All right. That was
Okay.
my one. Thank you.
Great job. Have a great weekend.
You too. Bye.
Bye.